Welcome to Mackie Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement. An equilateral triangular lamina of sides 25 rests on one of its sides on HP. The lamina makes 45 degrees with HP and one of its medians is inclined to the VP at 40 degrees. Draw the projections of the triangular lamina. So after having read the problem statement, we can arrive at a set of few conclusions. So the type of the plane that we are going to construct as a triangular lamina measuring sides of 25 So it is an equilateral triangular lamina, and then it is resting on one of its sides on the HP. So we need to have the edge of the triangular lamina towards the right hand side of the observer, and then it is inclined to the HP at an angle of 45 degrees. But however, with respect to the vertical plane, it is the median of the triangle which is inclined at an angle of 40 degrees. So now we will see how to solve this particular problem. So please make a note, this is not the edge on which it is resting which is inclined to VP, but it is one of the medians of the triangle which is inclined to the VP at an angle of 40 degrees. So now we will execute the solution of this problem. So we'll begin with selecting the line option, ensure it is a line of continuous type, and then let us draw the XY line of any arbitrary length and annotate this line as X and Y. So this is X and this is Y. And the plane above the reference line is VP and the plane below the reference line is HP. So now we will go ahead and construct the top view of the equilateral triangular lamina of thickness 0.50 because it is visible completely in the top view. So the side length is 25, and since it is an equilateral triangle, all the sides shall measure the same. And let us complete the top view of the triangular lamina and annotate the triangular lamina as ABC. This is corner A, this is corner B, and this is corner C. So as per our observation, a triangular lamina of side 25 is resting on HP on one of its edges AB. So in the second position, this triangular lamina is inclined to the HP at an angle of 45 degrees. Okay, so we will complete the second position now. So before that, let us depict the front view of this triangular lamina by drawing the projection lines. So it should be a line of thickness 0.13 So the front view will be on the reference line because the plane is on the HP. So using the trim option, let us trim this portion of the XY line and draw the front view of the triangular lamina. So the front view should measure 0.50. So this completes the front view, and let us annotate the front view. This is B dash and A dash, which is not visible and is inside the bracket, and this is corner C dash. So this is the front view of the triangular lamina. So this is the initial condition. In the next condition, this particular triangular lamina is inclined to the HP at an angle of 45 degrees. So we will construct this view also now. So for that, we will select the front view of the lamina along with the annotations. Go for the move option, ensure the copy is on, keeping B dash A dash as the center. Let us shift this to the XY line. Let us duplicate that and shift. And now we will go for the rotate option and ensure the copy is off. So this is the first point of rotation, and this is the second point of rotation. So we need to have B dash A dash on the XY line. So we will select the rotate option. This is the first point of rotation and this is the second point of rotation. So now the angle can be entered here. So the angle of rotation is equal to 45. So it is asking the direction. It is in this particular direction. So now we will draw the vertical projectors downwards and also the horizontal projectors from side and complete the top view of the triangular lamina. So projectors from A and B shall intersect the projectors from B dash A dash, and also the projector from C shall intersect the projector from C dash. Okay. So now we will just complete the top view of the triangular lamina in this position. So again, since it is visible, it should have a thickness of 0.50 mm. So this is the end point. So connect all the three endpoints and complete the profile of the triangle. So now let us annotate this. So this is corner A, this is corner B, and this is corner C. And always ensure that all the annotations pertaining to the front view are always above the XY line. Okay, so now we can use the trim option and trim the unnecessary projection lines in the top view. Okay, so now the problem statement is very clear that with respect to the vertical plane, it is not the edge on which it is resting which is inclined, but the median of the triangle. So in this position, what is the median? Suppose first let us understand what is a median. So a median is a line which is going to bisect the edge into two equal halves, and that median is going to pass from corner C and it is bisecting the edge AB. So I can call this point as M. So CM is the median of this triangle in the first position. So now let us see whether it is bisecting the triangle. So from this point to this point it is 12.5 and the total length is 25. So it is bisecting. So this is the point, the median point, correct? So this point is the median. And now let us see what is the length of this median. So from this point, so the point of intersection, and to the point C, this is the length of the median. Okay, that is 21.65. And similarly in the second position, let us draw the median line. So we can do that by selecting the extend to next option. Okay, so I will call this point as M1. So CM is the median in the first position, CM1 is the median in the second position. So here also we can just check if it is bisecting. So select this point and this point, and the distance is 12.5. Okay. So now let us measure the length of the median in the second position, which is equal to 15.31. So the length of this median is equal to 15.31. Okay. So now we can understand that the length of the median is not constant. That means whenever the uh, plane was inclined to the horizontal plane, the equilateral triangular plane was inclined to the horizontal plane at an angle of 45 degrees, the median length is appearing to be reduced. Okay, so when this is the condition, obviously with respect to the VP, we need to consider an apparent inclination because the given angle is the true inclination. But we are going to consider the apparent inclination to construct the position with respect to the VP. So for that, we need to construct the beta angle separately, as the given angle is phi, and the word appears to be inclined is not used here. So we will construct the beta angle and we'll follow this procedure. First, draw a line of any arbitrary length, and then from that line, consider a point, okay, any arbitrary point on that line, and then draw the median of length 21.65. So the point that we have considered is C, and the median that we are going to draw is CM. That is the median length from the first position. So the angle should be equal to the given angle of phi, that is minus 40 degrees. Correct? So this angle is phi, 40 degrees, and the length is equal to 21.65. So now we will draw the locus of the point M1. So the endpoint, we will draw the line parallel to the xy line. Okay, so this is the locus of M. So we can annotate this. This is the locus of M. So this is the given angle phi. So now how do we construct the beta angle? So after this step, so let us annotate even this point. This is C and this is M. So now keeping C as the point of center, we need to locate the point M1 on this locus of M. So for that, we will select the arc by center point. The first point of reference is C and draw an arc of length 15.31, which is equal to CM1. So 15.31 should be the arc length, and considering this as the arc length, I'm going to cut an arc and it should intersect the locus of M. So it is going to intersect at this point. So now let me draw the line connecting the point of intersection of the radii and the locus to the point C. And this is the point M1. So now let us measure the angle between CM1 and this reference line, which is equal to 65 degrees. So we will just recheck if the length of the median is equal to 15.31. So we'll just use the trim option for time being. Okay, so it is correct. So the value of beta here is 65 degrees. So whenever we are going to place this median CM1 on the line, so we have to construct a line of angle 65 degrees. So we will just redo this construction by using the extend to next option. So now let us draw a line of any arbitrary length, but the angle of inclination must be equal to 65. So this is a 65-degree line, which is the value of beta angle. So on the 65-degree line, we are going to place the distorted triangle. So for that, we will select the triangle. So since the median should also be selected, what we will do is we'll just trim this line for time being. So select the triangle along with the median and the annotations. And next, select the move option, keeping M dash M1 as the point of reference. Ensure that it is going to be aligned or placed exactly on this line drawn at an angle of 65 degrees. Now using the rotate option, since the median is inclined at an angle of 65 degrees, first point of center, second point of center, and rotate the entire triangular plane lamina. So now considering the line option, draw the projectors from corner C dash, and the projectors from B and A will be on the XY line. So now we will draw the vertical projectors upwards. So from corner A, it has to intersect the projector of A, and then from corner B, it has to intersect the projector of B. Similarly, from corner C, it has to intersect the projections from C dash. So now we will complete the triangle in the front view. So since it is visible, it should be done in the thick line. So first we'll complete this edge, that is BA, A to C and C to B. So this is the position of the triangle. So this is C dash and this corner is B dash and this corner is A dash. So this is the procedure to draw the beta angle. So we are going to consider the beta angle whenever the quantity which is going to vary in its dimension from the initial position to the final position is to be placed on the line inclined to VP. So that is, it could be a median, or it could be a perpendicular bisector, or it could be a diagonal. So these three parameters are going to vary from the initial position to the second position. And in such cases, whenever that particular parameter is inclined to the VP, that is the perpendicular bisector or the diagonal or the median, and then we are going to consider it as to be a beta angle problem. So let us just extend this projection lines. So now we'll indicate the direction of the projections by selecting the leader option, properties, change the color to black. So these were the projector drawn upwards. So this is the direction. And these are the projection drawn from left hand side to the right hand side. These are the projection drawn downwards. And again from left hand side to the right hand side. These are the projector drawn upwards. So using the trim option, trim the projection lines which is not required for us. So this is the construction of the beta angle. First, draw a line of length cm, mark the locus of m, then on this locus of m, measure this cm1, cut an arc, and then the measurement of the angle of this cm1 with this reference line is the beta angle. So the value of beta angle here is 65 degrees. So it is better we show the construction of the beta angle in a distinct position so that there are no confusions, and try avoiding the construction of beta angle in this position itself. So with this we complete the computer drafting of equilateral triangular plane resting on one of its edges on the HP and one of its median inclined to the VP at an angle of 40 degrees. Thank you all for watching.